The for loop is the workhorse of the loops. It's the one that's used the most often, and that's probably because it's the most flexible. Here's its structure. To create a for loop, you need to specify the initialization, the Boolean expression, the modification code, and the body of the loop. The initialization code is executed just once, and that's at the very top, right before the Boolean expression is evaluated. You can put any code you'd like in here, but it's normally code that initializes values such as counters that will be used inside the loop. Now, as you can see, it's terminated by a semicolon, so you might think that it can only be a single statement, but that's not true. It can be any number of statements, but you separate them by commas and then terminate the whole thing with a single semicolon. This is actually not as strange as it may seem at first. The syntax came directly from C, and in the early C compiler, you could string statements together with commas and use a semicolon as a synchronization point. A synchronization point is when all computations are completed and all values have been stored away. With modern compilers and optimization technology, that's no longer a factor. We just have a shadow of its syntax here left in the for loop. There is only one Boolean expression used for testing whether the body of the loop is to be executed. The first time through the loop, it's executed immediately following the initialization. If the body of the loop is executed, then the bottom of the loop jumps back to this statement to run the test again. As long as it's true, the body of the statement will continue to be executed. The body of the loop comes right after the test. If the test failed, that is, if the result of evaluating the Boolean expression was false, the body is not executed. Instead, a branch is made to the code following the stuff at the bottom of the loop, and things continue from there. However, if the test resulted in true, this code is executed and it drops through to the modification code that follows it. The last bit of code in the loop is the modification code. You can put anything you like in here also, but it's usually an update of the counters and such that get things ready for the next run through the loop. And just like the initialization code, you can include several statements here with all of them separated by commas. This is at the very bottom of the loop, and as soon as it finishes execution, there is a jump back to the Boolean expression at the top of the loop. This is an example of a for loop with two counters, both being initialized to 0. The value of I is increased by 1 each time through the loop, and the value of j is increased by 2. As long as the product of the two counters is less than 144, the loop will continue to execute. There is one special exception with scoping in a for loop. It's possible to declare a variable inside any pair of braces in Java and have that value exist anywhere within those braces. Now, this has been stretched just a bit with a for loop. You can see in this example that the variable named I is being declared outside the braces that define the body of the loop. Well, the variable is treated just as if it were declared inside the braces. That is, it exists inside the braces, but after the final brace at the bottom of the for loop has been reached, the variable named I has vanished. For purposes of variable scope, anything declared in the for parentheses are treated just as if they had been declared inside the for body braces.